So on the last page, we had the dependent and consistent, where the two lines or the two equations give the same line. On this one, we're going to do independent, which means they're not multiples of each other, and inconsistent, which means there's no solution. And the way this will look when you have two equations, if you write them in this form with the x and the y term on the left and a constant on the right of the equation, then you'll notice the left side, the second one is a multiple of the first. It's a multiple of 2, right? If you take 2x plus y and you multiply those by 2, you get 4x plus 2. But I did not multiply the right side by 2. I just have the number 2. It would have to be 6 here for these two to be the same equations for the same line. This would have to be a 6 here. You take everything and multiply it by 2. I multiplied the x coefficient and the y coefficient by 2, but I didn't multiply the 3 by the same thing. And this is how you end up getting two parallel lines that are not the same line. And so this will be inconsistent. So they always look like this. If you write them in this form, they always look like this. Of course, it could be a different multiple here, but these ones here will be a multiple of these ones here, and this will not be the same multiple of this term here. Okay. So these are, I just wrote it out for you. These are multiples of each other, and these are not the same multiple. Not multiplied by the same number as on the left. And if I write both of these, solve for y in both of these equations, I get these two different equations. You can see what happens. You get y equals negative 2x plus 3 and y equals negative 2x plus 1. They're the same slope, but one is shifted differently. One is shifted from the going through the origin. It shifted up 3, this one. And from the one going through the origin would be the y equals negative 2x, right? So I've shifted that up 3. This one I've shifted it up 1. So they're two different lines, but they are parallel. They have the same slope, negative 2. Right, but you can tell by solving for y, you can tell that if you want to do that, but it's easier just to look at this and say, oh, well, this is twice that, and this is not twice that, so the two parallel lines that are not the same line. So there's no solution, which means it's inconsistent, right? But they're still considered independent. Okay, and then this one is independent and consistent. It means it has a solution and they're independent, and this is when you get a single solution. So the left side, you'll notice the x and the y term are not multiples of each other. If you take, okay, so this x is negative a half times 2, and if you take negative a half times y, you don't get what's here. See, so they're not. Or you could look at it this way. This is 1 times y, and this is not 1 times 2x, right? So these are not parallel, and that means they're going to have a single solution, because when you have two variables and they're not, they're representing lines, and if the lines aren't parallel, then there's a single solution. And if I graph these, you'll see I put them in y-intercept. One of them I put in y-intercept form. Y equals negative 2x plus 3. And the other one, I just graphed it directly, negative x plus y equals 0. Really, the easiest way to graph these when they're in this form here is to find the x and y intercepts and then just connect those with a line, right? But I did them this way. I did one of them that way, and I did one the other way. Okay.